Hello everyone, in this video I am going to explain about deep learning DL. Deep learning is a subset of machine learning, which is again subset of AI, artificial intelligence. Deep learning uses multi-layered neural networks to automatically learn complex patterns from data. So basically it's a multi-layered neural networks. Okay, in case of single layered networks, ANN, artificial neural networks, they are less powerful compared to deep learning, which is multi-layered neural networks. Okay, so deep learning will be having more than one network layer. Okay, it will be able to automatically learn complex patterns from data. Because of this multi-layered ability, it will be able to automatically learn complex patterns from data. Compared to traditional machine learning models, it will be able to learn complex patterns. Okay, so that is why now we are using in almost all kinds of AI applications, we are using deep learning. Okay, so we will be able to use it for various kinds of AI applications, including large language models like ChatGPT, Gemini, that are powered by transformer architecture, which is using deep learning. Okay, but the thing is, it requires large data for training purpose, and it needs a lot of computing power. Okay, that is the reason why deep learning was not that much useful when people started developing neural network algorithms long back, many decades back itself. Okay, so the algorithms began deep learning like backpropagation. They were developed long back. Okay, but they are not much useful because lack of computing power. Okay, so basically it is inspired by the human brain, right? So scientists try to reproduce the functionality of the human brain. So that is how the research related to neural networks started. But these days, especially the deep learning, they're just working in somewhat different way from human brain functionality. Okay, but basically overall we can say that it is just trying to reproduce human brain functionality. Okay, so next, why we have to use deep learning over other traditional machine learning models, right? The main reason is deep learning learns features automatically. Okay, in case of any kind of machine learning model training, especially related to supervised learning, we have to provide the input features and labels, right? In this case, we have to manually, in case if we create the features manually, it will require a lot of time. It needs a lot of human work. So basically it is expensive, and it will take a lot of time, right? But in case of deep learning has the ability to learn features automatically. So no need to do the manual feature extraction. Okay, so in that case, it can be done very quickly, and it can save a lot of money also. Okay, so that is the reason why almost all the modern AI applications are powered by deep learning. Okay, it works well for various kinds of AI applications, including images based things like face recognition, text based language translation, and audio based speech recognition. So almost all the modern AI applications are using deep learning now. Okay, next, how deep learning works. Okay, it's very important to know the fundamental of deep learning functionality. Basically, as I said previously, it is just trying to reproduce the functionality of human brains, which are powered by neurons. The same concept they're trying to reproduce with the deep learning. So basically neural networks. Okay, let me explain it with TensorFlow playground. There you can just check various things. Okay, it's kind of simulation. Okay, it's not actual coding. We can explore various things there, and then you can start using in your programming. Okay, so let me first start with this playground. Okay, this website playground.tensorflow.org. Okay, playground.tensorflow.org. It is provided by Google. Okay, you can just visit this site from your browser, and you can just simulate the things like you can set various parameters here, and you can just do the training. Okay, training, it's not the exact training, just it's kind of simulation. Okay, so that you can learn the things very easily. Okay, so it's basically neural networks. In case of deep learning, as I said, it should be having multi-layer things, right? Input layer, output layer. In between them, we can add many number of hidden layers. Okay, we get, with the plus, if we click plus, it will be adding another hidden layer. If you click minus, it will be removing that. Okay, similarly, for each layer, we can add multiple neurons. We can add and delete also. Okay, we can delete the neuron, we can add the neuron. Okay, so basically that neural network is the brain functionality, right? So it's just similar to synapses, neurons, that concept. It is just connecting the neurons, okay, through it's like weights. The connections are powered by weights and biases. Weights are nothing but just a number multiplied with the input value, and bias, that number will be added to the input value. Okay, so it's a fundamental. So basically, whenever we train the model, deep learning model, that means we are just trying to find appropriate values for that weights and biases for all these connections between neurons. Okay, that is the fundamental. Okay, so the ultimate aim is finding appropriate values. Appropriate values means once we set that appropriate values, the model should be able to predict any kind of unseen data properly. Okay, say for example, if you train that model with some 10 cat images, and if that model is able to set the weights and biases properly at the end of the training, that means whenever you give some additional new kind of unseen cat image to that model, it should be able to identify the cat. But that is our purpose. From training purpose, it is like at least it should be able to find all that 10 images, whatever 10 images we use for training, it should be able to identify without any error. Okay, it should be 100% correctly identify them. Okay, that is the training process. Okay, but if it is working properly, then it should be working for unseen data also. That is the fundamental of AI, right? That machine learning concept itself like that. So here, for understanding deep learning, we can assume that at the end of the training process, that biases and weights should be calculated in such a way that the training data, whenever we test the model with training data, it should be working properly. Okay, so that is the thing. So ultimately, making the error very negligible or zero. Error means difference between expected thing and predicted things. So each training process, it is finding the predicted value, and predicted value we know because the training data, right? We know the expected thing, and it is calculated things will be there. So finding the difference. Okay, so that difference findings will be done by loss function. A lot of loss functions are there. Score, mean, root, because the reason is in case of difference, say for example, expected value is 10 and predicted value is 12, the difference is 2, right? Even if it is 8 and 10, again the difference is 2, but minus, right? But we care about the difference. Okay, so whether it is plus or minus, we don't care, right? So in that case, we can use that root of mean score, like that. Different ways are there. Okay, so that is a loss function. So we use loss function, okay, for finding the difference. We use activation function for introducing the nonlinearity. Okay, that here you can see the activation function, right? ReLU, tangent, sigmoid, linear. These are all used for introducing non-linearity. Okay, it's very important because fundamentally we see that deep learning is for identifying complex patterns in the data. Okay, it is for identifying complex patterns. Okay, in case the patterns data are like this, the simple things, we can just draw a linear line, right? Just a straight line, linear line is enough to group these kinds of data. If the orange one is males, and just assume that blue ones are females. If you draw like this, if any new data is coming here, we can easily say that they are males, right? That can be done with simple linear regression, that kind of simple traditional models, right? Machine learning models. But the purpose of deep learning is identifying complex patterns, something like this. Okay, so if it is the data is like that, then our curve also it should be very complex one, bending one, right? To find the patterns like. So in that case, we need to introduce non-linearity. So a lot of different things are there. So we got to choose based on our use cases. Okay, ReLU, tangent, sigmoid, linear. That is activation function. So as I explained previously, loss function is for finding the difference between predicted value and the expected thing. So that difference, I mean the loss value is used by optimizers. Lot of optimizer functions also, optimizers also there, Adams like that. So they will be correcting the, I mean changing the weights and biases so that it can help to reduce that loss. Okay, so but it can go in iteration, right? Epoch, we can set the epoch here. So at the end of the iteration, so it should be error should be 0, but we cannot expect always the 0 error. A lot of other things are there for handling the end of iterations. Either we can set number of epochs, or we can use early stop like that. Okay, a lot of things are there. Okay, so the ultimate thing is we got to find the weights and biases. That is the ultimate purpose. For that we got to use optimizers, activation. Regularization is to avoid the overfitting. Okay, L1, L2, lasso, ridge, that kind of regularization things are there. So regularization is to avoid the overfitting. Okay, as I said, that key purpose of deep learning is for handling, or for using it for finding complex patterns. So in that case, as I said, we are introducing nonlinearity so that it can find the complex things. But if it is 100% or it's very closely matching with training data, means it won't be able to handle the other unseen data, right? So it is, if it is trying to expect exactly same training data things, if it is close, it is overfitting instead of generalization. It is depending it is very inclined towards training data. Okay, it's not useful, right? So the ultimate purpose of AI, the fundamental is it should be generalized. Otherwise the traditional programming also, we can just if we are just going to compare with some particular value, or we can use traditional programming, right? So instead of doing that, the unique nature of AI is finding patterns. Okay, generalized way, not training data is just to give some understanding about it, not to just exactly follow that, right? So in that case, we have to use regularization to avoid overfitting. Okay, these are all the things. And the problem type, we can choose classification or regression, just identifying whether simple things like classification, things like spam, not spam, fraud, not fraud, like that, or regressions like house price prediction, stock price prediction, that kind of stuff. Okay, so I'm just giving some overview, but you can just explore the things. You can set the value and how it's getting changed, like that. You can just you can set number of you can see the epochs, so how the loss is getting reduced. Here you can see the values, right? So as I said, getting 0 is a bit difficult. If it is getting 0, then it's okay. Otherwise we have to use some kind of early stop, that kind of stuff. Okay, so otherwise it will be keep on going. Okay, so it's taking a lot of time. Okay, so that kind of understanding we can get from this kinds of playground, and we have to implement it in our coding. Okay, so now it reached 0 loss. Okay, so in that case these weights are okay, so we can use these kinds of weights. Okay, so ultimately whenever we train the model, if we are saving the model, means it is the values of weights and biases of the neurons. That is the trained model. Okay, ultimately the trained models will be having weights and biases of the neurons. That is the purpose of the training in deep learning model. Okay, so this is the training process. Okay, we can choose learning rate also. So if we are choosing high rate, then it will be like completed very quickly. If you select the rate low value, it will take more time. But we have to choose the appropriate value. It's like jumping a valley kind of thing. It's this like exact analogy for understanding these things. Okay, as in simple mountain, if it is particular height, we can go there by jumping step by step, right? But if we jump very high, we can go beyond that thing, right? But if we choose little jumps, then it will take more time to reach the mountain. Okay, so that's the same thing here. Okay, so we have to choose appropriate learning rate. Okay, so epochs, as I said, it's a common thing, right? Number of iterations. A batch size, in case if you are choosing a lot of data, processing all the data simultaneously will be very difficult. It will require a lot of computing power. So we can choose batch size. Okay. So we can test with various layers. Okay. But the thing is, if we increase the complexity of the model, that means if we add a large number of neurons and number of hidden layers, then the overfitting will occur. Okay, so we need to keep the model very simple. But if we keep very simple, then underfitting will occur. Even it won't be able to identify the training data itself. Okay, so we have to explore various things, and then whenever we develop the coding, we can use these things. Okay, but in recent development, that frameworks are having a lot of features for tuning these parameters automatically. Okay, these are all hyperparameters: learning rate, activation, regularization. So that things manually doing is based on our experience we can do. Okay, or we can do it by like trial and error, that kind of stuff. So it's a combination of various things. Okay, but AutoML is trying to do them automatically. So a lot of cloud-based service providers are implementing that, providing that feature. Okay, but we don't know whether they will be really optimized. Better we have to explore manually also. Okay, so this is the fundamental of deep learning. So we have to set the appropriate value for weights and biases. Okay, and for that we have to use loss function to find the difference between predicted and expected values, and based on that value, with the help of optimizer, we have to correct the weights. Okay, it's back propagation. Okay, fundamentally. Okay, simple example is just classifying the image. Okay, deep learning can automatically learn edges, patterns, object parts. Okay, so that it can identify whether it's a cat or dog. In case of traditional machine learning, assume that if you want to classify cat and dog images, in case of training, we have to do a lot of manual work to find the edges and the patterns, even object parts. So all these steps needs to be manually done. Okay, so for example, edges in the sense, if the training data is having multiple animals, we got to manually point the edges of that cat image, so that that training process can identify that. Okay, and similarly a lot of things, even object parts. Suppose if the training process depends on the actual part of that animal, then we have to specify that this is eye, this is ear. Okay, it is leg, like that. Okay, that will be taking a lot of time, right? It's it needs a lot of manual work also. Okay, but in case of deep learning, everything will be done automatically. Okay, so that is the key advantage of deep learning. That is why everyone is now using deep learning for any kind of application. So the difference between deep learning and traditional machine learning is, in case of feature extraction, traditional machine learning is manual. Here in deep learning, it is automatic. Okay, that is, as I said, that is the key advantage of deep learning. It will help us to save a lot of time and money. And data recommend is, in case of traditional machine learning, it is less, deep learning more. Okay, so if we have only limited data, then we have to go with traditional machine learning, which is effective in that case. Okay, But deep learning requires a lot of data. Okay, so we need to keep that in mind. Okay. In case of performance, traditional machine learning will be good even with less data. But in case of deep learning, it will be becoming better only when we provide a huge amount of data. Okay, speed, traditional machine learning will be faster, but deep learning will be slower. It needs GPUs. Okay, huge computing power. Okay. So, based on the use cases, we can choose with the traditional machine learning or deep learning based on our use cases and our availability of resources. Okay, but fundamentally, from these differences, we can understand that deep learning is better, but we have to use a huge amount of data and a lot of computing power, right? That is why big companies came up with the plan of LLMs or any kind of foundational model, training the model with a lot of data with a huge computing power. So it's a one-time process, right? After that, anyone can easily using that model. So that is why this generative AI, that kind of LLMs became very popular, right? So now everyone is using LLM based AI applications, right? We can just access them through API, or we can put up them in our local also. Distilled versions we can put in our local. So a lot of the developments are happening in that direction. So all because of the difference between this traditional machine learning and deep learning. So deep learning will work better with a huge amount of data. It needs a lot of computing power, but it will help us to save a lot of time and money because of the automatic feature extraction, that thing. Okay, so it is very good at finding complex patterns in data. Okay, so common deep learning architectures are CNN, convolutional neural networks. They are used mainly for handling images. Okay, so YOLO, that kind of models are using CNN based things. And RNN, recurrent neural networks, it is for like text and audio processing. That the LSTM models also are using that architecture. Transformer, it is very important one. Okay, so almost all the advanced things like chat GPT, that LLMs, all kinds of LLMs are using transformer architecture. Okay, NLP stands for natural language processing. Okay, so ChatGPT, Gemini, all models. ChatGPT in the sense internally it's using GPT model, right? So that models are transformer models. So a lot of applications, almost as I said, face recognition, voice assistant, recommendation systems, self-driving cars, almost all the applications, AI applications are now powered by deep learning. So challenges in deep learning, it needs a lot of data, I already explained that, and a high computation power. So that also we discussed that. The other challenge is hard to interpret, black box kind of stuff. Okay. These days, everyone is talking about explainability AI, right? XAI. So we should know what is happening behind the uh, uh, process of AI, right? Like suppose if AI is giving some output, we should know why it has created that output. So we should be able to know that, right? So that kind of expectations are not there. But in case of deep learning, it's a bit difficult to know the reason behind its functionality. Okay, it's a complex nature, right? Okay, and a risk of overfitting. So we got to carefully choose regularization, other things to handle that overfitting. Because it's able to find the handle the complex patterns. In that process, it will be inclined towards more training data. Okay, so we need to consider that factor. Okay, popular deep learning frameworks are like TensorFlow. It is Google backed. It is production ready. Okay, and PyTorch. It is Facebook, provided by Facebook. Okay, and it is popular in research and fast prototyping. Keras, it's a high-level API, runs on top of TensorFlow. Okay. In case of Keras, right now it is built in with TensorFlow. Okay, so we can use TensorFlow alone, and within TensorFlow we can use the Keras features. Okay, so basically Keras will be making our coding process very simple. It's a high-level API, and recently PyTorch is getting more importance. Okay, but People are saying that TensorFlow is more effective for production ready. That is one point. Okay, but still PyTorch is now becoming very popular. In that case, even it will be it will become suitable for production very soon. Okay, if you're planning to start using deep learning development, it is better go with PyTorch now, because but if you are planning to read some old examples, or if you are planning to previous sample applications, that will be in TensorFlow. Okay, and okay, anyway, TensorFlow is still actively there. You can explore both things, and whichever is compatible for you, you can go with it. Okay, so activation function, we noticed that in the TensorFlow playground, right, is for introducing nonlinearity, ReLU, sigmoid, tangent, lot of things are there. Okay, thanks for watching this video.